How to see anticrepuscular rays. Next time you see a crepuscular ray or sun rays extending from the horizon, turn around, you might catch a glimpse of elusive anticrepuscular rays. We've all seen crepuscular rays or sun rays converging on the sun. They appear as columns of sunlight streaming up from the horizon or down through gaps in the clouds. Next time you see them, turn around. Look the opposite direction of the sun and you might catch a glimpse of the elusive anticrepuscular rays. These rays appear to converge towards the antisolar point, that is to say, the point on the sky opposite the sun. If you want to see them, remember these 3 tips. 1. Look in the direction opposite the sun next time you see crepuscular rays. 2. Look carefully. Remember that anticrepuscular rays are fainter and more elusive than crepuscular rays. And 3. Watch around sunrise or sunset for them, because that's when they are most frequently visible. So, the only thing that needs to be noted is, if we're facing the sunset or sunrise, we will see the light appear to emanate from a source, rise in our perspective from the horizon to the upper half of our vision. If we turn around, we will notice exactly the same phenomenon, which proves that it is perspective, because we will see the light directly above our head, do exactly the same, and descend down to what would appear to be a localized light source. But of course, as we know in the case of anticrepuscular rays, that's simply not true. Okay, so in the case of trying to make a balanced argument, we can see a picture here which demonstrates perfectly the globe view. So I'll read it out. Since the sun is what's making this light, then the angle of each ray indicates the direction of the sun. That's absolutely incorrect, because we've just proven that with anticrepuscular rays. All it proves is the direction of the light. So I'll move on. As shown in the second picture, the sun must be below the horizon. That's also absolutely incorrect. It just needs to be further than the horizon. In the flat earth model, this is impossible, and no amount of bleating perspective or optical illusion will fix it. So, what we're being told here is that those crepuscular rays, as you can see on the image, are emanating from the sun, which is now behind the curvature of the earth from our perspective in this image. What I am saying is it is beyond the horizon, it's gone past the horizon, and its light is emanating and will move closer to us, and as a result higher in our perspective. This is 100% proved by anticrepuscular rays. So you cannot use this argument using crepuscular rays when anticrepuscular rays completely debunk your argument. Here's a very simple definition of a very simple thing. The horizon, the line at which the Earth's surface and the sky appear to meet. They do not actually meet, they appear to meet. Every sunset and sunrise takes place at the horizon, which is where perspective has caused the line at which the Earth's surface and the sky to appear to meet. When every sunset or sunrise takes place from this point, then it becomes statistically impossible to argue that it is generated by anything other than that point. Right, so let's try and justify what we've been told about the globe model. And if we look at this awesome sunset, we can notice something, if we're honest. First thing to notice, obviously, is those folks on the beach there enjoying that glorious day aren't spinning at 1,000 miles an hour away from that sun. Now, you could argue that point with me, obviously a great deal, but you genuinely have absolutely no proof other than what exists in your mind, what your mind is made up, because there is absolutely no truth in it. So what those people on the beach are watching is that sun move further and further and further away until such time it moves past that horizon. But what's really important is we are told that that horizon is actually the mass of the Earth blocking the sun, blocking the sunlight. But when that sun, in any sunset or sunrise you see, moves past or to us from the horizon, the lighting doesn't change. Now, if we were on a planet spinning away, as soon as that sun disappeared and the mass of the Earth blocked it, it would be, well, instantaneous and extremely, extremely noticeable. But what we can see in all these images is the fact that the sun moves further when it is beyond the horizon, nothing gets pitch black. In fact, the lighting remains virtually identical. Now, I've sped this footage up a little bit, obviously, but you can see it's not going incredibly fast. There's people, there's birds, and just to give you a general idea of how quickly that sun is moving away. We are not changing our degree of visual inclination on that object by spinning away. It is clearly moving away. And once it moves fully past the horizon, which is generated by our perspective, then you would expect, if it was in fact the mass of the Earth blocking it, there to be virtually no light. And in fact, once the sun in this video has gone past the horizon, it remains to be light for quite some time. And I suspect the person who's taken this footage, if they had turned around, it would still be light. So how could we have moved such a great degree of inclination in such little time? So apparently the whole planet is spun away, the sun is no longer visible, and yet the light remains hardly unchanged. Anybody with an ounce of common sense can determine that if there was the huge mass of the planet blocking that light, the light would suddenly change. It's not. It's constant. The sun is now set in this video, and yet the lighting remains constant, because until the sun gets even further away, obviously nighttime won't have fully descended, and nothing to do with spinning around, because we would be in pitch black by now. If we've changed our inclination on the sun that much in that little time, all this time, we'd be in absolute pitch black, right? But it's not happening. Despite the speed then that we've just seen the sun disappear, we should therefore conclude that every moment following we are speeding further into the void of blackness, but clearly that just isn't taking place. Here are 3 lines drawn on an image. The lowest line is A, the middle line is B, and the top line is C. If we look at the water between A and B are the same height. If we look at the sky between C and B, they are the same height. Therefore, the horizon, as illustrated earlier, is simply where A and B join C and B in our perspective. It is also where every sunset and every sunrise will ever take place from. As a consequence, it therefore must be due to perspective.